Oh, and we'll play a little ultimate. Did you play ultimate frisbee last year, Mrs. Stone? Yeah. What?
Yeah.
No, it's not.
Calibrated.
No, it just doesn't want to go across that crap. You did play?
Yeah.
Was it any fun?
Yeah.
Sure.
Well, it'll be more fun this year. Very good. Wait, did I turn this on? Yes, I did. Under sequences, and we talked about this a little before, right? Did we not? Somebody asked a question. Was there not a question on the test about this? Just say yes.
Yes.
Okay, so here we go. Just remember this. Usually in these things you have the letter A and you usually have the letter N. The letter N is, remember Mia? Well, it's the number of the term, yeah. Okay. A just means the value of, I guess. The value of. So if you're given a sequence that looks like this, a to the sub n equals 3n, a to the sub n equals 3n, that means this. If you were making a table, usually we make it like this, although a lot of times we go up and down. If you're making a table, the top number is the number of the term, that's your letter n. You can go 1, 2, 3, 4, 8, it doesn't really matter, okay? So when you plug it in this formula, a sub n would be, if you're looking for the first term, you put a 1 there, and that just means what that is, the first term. That's a value of the first term. Equals 3, and then you just put whatever the number in the first term is, 3 times 1. Okay, so the letter A down here would be 3. The second term would be 3 times 2, which is 6. Third time, 3 times 3, which is 9. The fourth term, 3 times 4, which is 12. And that would be, what, 24. Which is all well and good. The formulas are easy. It's trying to find the formula when you're given the things that's the hard part, right? Yes, Mr. Hunt, that is incredibly difficult. Let's check and see if we can't do one there. Let me find one here. We did one. One was on the test there. Let me see if there's another one here. So here, look at this one. 2, 3, 5, 9, 17, 33. And I may not be able to do this, but hey, we'll try. Well, maybe I don't want to go that one. Sorry, I'm not going to do that one. Let's do this one. 3, 8, 13, and 18. 3, 8, 13, 18, and so on, and so on, and so on. How in the world would you find the formula for that? Anybody know what it is by chance? Logan says,
+5 every time.
what?
Every time it's +5.
Well, it is +5 every time, but that's not my formula. What would you say the formula is? Remember, it's got to be in the form of a sub n would equal what?
5 +
N plus 5? So does that work? Remember, this is the first term, second term, third term, fourth term. Let's do our little box. So if I put a 1 in for the letter n, 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. Somebody give me a formula that'll work. I want one that'll work, kids. That was a good try, Logan, and I agree. And that's part of it. Logan kind of hit the key. The first thing you look at is, he doesn't like that spot. You do definitely look at what happens between each term, because that's going to be part of your sequence. What does happen, Logan, every time you add 5, right? Now here's what you have to remember, though. Okay, here's what you have to remember. Think about this. Let's start at 0 and add 5 every time. okay, I am not taking a number and adding 5 to it. How do you end up with, if this was your terms, how do you end up with that? What do you do with this to get this, 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 with this to get it? You don't add 5 every time, you, yeah. If it's an adding 5, like sequence thing, it's actually gonna be times 5. Because like, so you're, this is, well, this would be minus 5, but every time you're multiplying by 5, you know, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, and that is, when you go from one to the next, that's like adding 5 another time. So 5, when it's plus, when you're adding 5 between each term, 5n is going to come in there. If it's addition, it's going to be multiplication in your formula. Okay? But that doesn't work either, because if I put 1 times 5 in, I get a 5 here instead of that. If I put 2 times 5, I get a 10. Now you have to just adjust it by adding or subtracting everything there, which is, Taylor?
5n minus 2.
Yes, 5n minus 2. So my adjustment is, yes, I'm multiplying by 5, but to get my starting place, or to move it, to adjust it, to shift it the way I want, I need to subtract every time. Does that work? Well, if I do 4, my fourth term should be 18. 5 times 4 is 20. 20 minus 2 is 18. Okay, so be wary of that. If it's adding 5 each time, it's going to be multiplying by 5 here. Now, let's throw a little wrench into the whole thing and take a look at this one, because I think you'll like this, maybe not. 1, 3, 9, 27. 1, 3, 9, 27. And dot, dot, dot. My recursive formula. Somebody? Well, first thing again, think about drawing the box here. Blah, 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 blah. This is the first term. These are the ends. Second term, third term, fourth term. Well, if you look at the relationship between the first term and the number you get, you could just say, well, it's just itself. Right? But that doesn't work here because your answer is not 2 there, right? So that ain't gonna work. Well, just like before, look at what happens between each term here. How do you go from 1 to 3, from 3 to 9, to 9 to 27? Get on. You multiply by 3. Well, now we're in uncharted worlds. Last time it was adding between terms. This is multiplying between terms. Guess what multiplying between terms is going to do? What is it when you do 3 times 3 times 3? When you multiply by 3's, it's exponents. So if you see something, the terms, if you see terms, and to go between them you have to multiply, that means somewhere in this thing, you are going to get an exponent. Now, does that work? If you take n, and because it's 3, I'm going to put n to the third power. Does that work? What is 1 to the third power? What is 2 to the third power? Doesn't work, right? Let's flip it around. What if it is not n to the third power, but 3, oh great. What if it would be 3 to the n power? Does that work? What is 3 to the first power? 3 to the first power is? 3 to the first power is? On the count of 3, everybody. 3 to the first power?
3.
One more time, just a little louder. 3 to the first power?
3.
3 to the second power? 9. 3 to the third power?
7.
Look, you've got 3, 9, and 27, but that's not, it doesn't match up with the ends there, does it? Because 3 to the second power was 9. 3 to the third power was the 27 there. How can I adjust that? How do I fix that? Are you gonna say subtract? Would that work if you said subtract 3 from it? Now, they would be fine if instead of a 2 I had a 1, right? And instead of a 3 I had a 2. What can I do? I'm not doing subtracting from that. I am going to Ryan.
Subtract 1 from n.
Exactly. You're gonna take the exponent and subtract 1 from it, and then it'll work, watch. Because, let's say my n is 1, what is 1 minus 1? 0, what's 3 to the 0 power? If my n is 2, 2 minus 1 is 1, what's 3 to the first power? And so on, and so on, and so on. So it gets a little tricky, and that's why this math gets a little tougher, you just have to think about it. Let's try another one. I don't know if they give you a harder one. I'm gonna find one. I'm looking at something that I don't understand. Let's try one. I don't know if I get it or not. Something I have here. 359. Did we do 359, 1733? No, let's not do that one. 1, 4, 16, 64. That is my, what would be the formula for that? What would be the formula for that? Somebody get it? Like I said, the first thing you want to do is kind of make your little table so you know what the deal is with the terms. First term, second term, third term, fourth term. Then look to see what's happening between these things. What's happening every time? Times 4, times 4, times 4, right? So what's that going to be? Out?
A n equals 4 n or 1 power minus 1.
4 to the power minus 1. Same thing as the 3, except this time you're multiplying by 4. Are you good with that? Kind of ish? They won't ask you a lot of questions on this. I mean, this is not like one of the super big heavy hitter sort of things there. Right, for tomorrow then,